It is given to me that the box here has a volume of 300. So if the volume is equal to 300, which means that x multiplied by 3x multiplied by y is going to be equal to 300, which means that y is equal to 100 divided by x squared. And if I were to let the external surface area be A, which means that A is going to be this surface, which is the same as this surface behind, so it is 2 times of x, y, and this surface here, which is the same as this surface, it is going to be 2 times of 3x times y, and the bottom surface is going to be x times 3x. Then I'll plus the external surface of the lid. This and the behind is going to be exactly the same, so it's going to be 2 times of kx times x, plus this surface and the other surface is going to be the same, so it is going to be 2 times of 3x times kx, plus finally this top surface here is going to be just by itself, so the top surface is going to be x multiplied by 3x. And if I were to simplify this, A is going to be equal to 8xy plus 8kxy plus 6x squared. And if I were to group the xy terms together, what I'll be getting is 8 times of 1 plus k of xy plus 6x squared. And we do know what is y in terms of x. It is what we have found out here. So it is 8 times of 1 plus k x of y, which is 100 over x squared plus 6x squared. Which means that what we have now is 800 of 1 plus k divided by x plus 6x squared. And since we want to find the minimum total external surface area, I'm going to do a dA dx. So dA dx. Differentiating this with respect to x, it is minus 800 of 1 plus k divided by x squared. And differentiating this with respect to x, it is 12x. And since we are trying to find the minimum, it is a stationary point. To find the stationary point, we will definitely let dA dx be equal to 0. So if we were to let dA dx be equal to 0, which means that minus 800 of 1 plus k divided by x squared plus 12x is going to be equal to 0. So 12x is going to be equal to 800 of 1 plus k divided by x squared, which means that x to the power of 3 is going to be equal to 200 of 1 plus k divided by 3. So x is going to be cube root of 200 of 1 plus k divided by 3. So what we have found out so far is that when x is equal to this value here, A is going to be experiencing a stationary value. But what the question one is that this is not just a stationary value, we need to prove that this is a minimum value too. And to do that, I'm going to use the second derivative test, which means that I'm going to find d square A over dx squared. So d square A over dx squared, that means I'm going to differentiate this, which is the same as minus 800 of 1 plus k x to the power minus 2 plus 12x. So differentiating that, it is going to be equal to 1600 of 1 plus k x to the power of minus 3 plus 12, which is 1600 1 plus k divided by x to the power of 3 plus 12. And x is this, which means that x is positive. And if x is positive and it affects only the denominator here, to the power of 3, it is still going to be positive. And k over here, it is between 0 and 1. So 1 plus k is also going to be positive, which means that d square A over dx squared for x is equal to this is going to be bigger than 0, which means that A over here, it is a stationary point and it is also a minimum point. That is why to give the minimum total external surface area of the box and lid, x has to be equal to the cube root of 200 1 plus k divided by 3.